Welcome to another Python class, and in this lecture we are going to be taking a look at exceptions. Now, what do we mean by exceptions? So exceptions refer to when something exceptional, not necessarily in the positive, mostly negative, when something exceptional has happened in your code. And let me give you an example. Imagine I want to say something like name equals to, and then let me say something like Lucas. All right, let me say name equals to something like all right, Lucas. All right, and then let me print the name. Okay, so let's print the name, and let's come over here. So now you can see we have something called syntax error. So now this is an exception. Something has happened in my code that Python seems not to be comfortable with. Syntax error, unterminated string literal detected at line 3. So that means on the third line there was a string literal that was not terminated, because of course this needs another quote over here. So it tells me syntax error. So that means the way I wrote the code on line 3 does not match the syntax of Python. Every language has its own syntax, the same way programming languages themselves have their own syntax as well. So this here is what a syntax error. So this is an example of an exception. But now what we can do is we can now program defensively. Let's say we are trying to ask a user for a number, or let's say a score, or let's call it a number instead. So let's say number, and then we say something like let's put this int, and then let's say this should be let's say input, and then let's ask the user for a enter a number. All right, so let's say enter a number. So let's do this, and then we want to print that number. So obviously here we want the user to give us a number, not an alphabet. Okay, so let's do this. So let me run this now. So let me say 6. Now this gives us 6, but what if I say something like ABC? It now tells me a value error. So a value error occurs when you pass a value that is actually valid. It is a valid data type here, but it does not work for the kind of operation that we want to perform. ABC is a string. It is a valid data type, but we cannot convert a string like ABC. We can't convert it into an integer. So that there is a value error. The problem is not with ABC. The problem is we are trying to convert ABC into an integer, and it is not going to work for that kind of operation, value error. So we have different kinds of error. We have zero division error. Imagine I try to do something like okay, let's do this, and then let me just say print number divided by 0. So let's even run this. Let's say this number should be like 6. Enter. Now I get another kind of error, zero division error, division by 0. Because why? You can't divide any number by 0, and that's why this gave us zero division error. So now let's not try do these things when it comes to exceptions. So one way we can solve the problems with exceptions, why don't you just do this? Let's turn this to x, and then let's convert it into an integer as well. So and then let's take the input from the user, and then let's ask the user what is x. Okay, all right, let's do that. And then maybe I want to print this x. So let me try the code again. Let's use our f string maybe, and then we can say x is s is x. All right, so let me do this and see if everything works well. So let me do 8. All right, x is 8, and then let me do a, b, and then it is still giving us our value error. But there's a way we can program defensively in a way that even when the user makes a mistake, that there's an error in what the user gives to us, it does not end our program this way. We are able to tell the user what has gone on, not this cryptic results or response that Python is giving us. So now, and then to do that, we can do something like try. So that means we want to try to do this first, and then I can put all these ones in the tab. Try to do this first. Try to take this input from the user. X equals to int input what is X. Ask the user for X, right? We want to print X is X. Otherwise, and then we can now use except. Except what? Well, except there is a what? There's a value error. And then we can now tell the user that, you know what, X must be a number, and then we say X must be a number. All right, so let's try this and see what we have. What is X? 5. X is 5. What is X? Let's say AB, and then it tells us X must be a number. So we have caught this particular error called a value what? A value error. And then it tells us X must be a number. So the user knows that, oh, okay, X must be a number, and then they know to correct themselves. But there is a catch over here. Imagine if I am not doing this over here, and I come here now and I say, let me print X. All right, so let's see what's happening over here. Let me run this, and then let me say 5. X is 5. Let me say AB, and then it's telling us, oh, X must be what? Must be a number. So either way, it works. Now, but there's something we must understand over here. Imagine, let me just come over here. Let me go back to what I was doing before. It could have worked anyway. So now, I can as well just say except. I can say except. Now, when I say except, let's try this one as well, if it's going to work. 5, X is 5, AB, X must be a number. What then is the difference between me using except and except value error? All right, now imagine that I'm not trying to say print X is X, and then I also now want to print, let's say X divided by 0, for example. I want to print X divided by 0. So let's do this. So let's say 5. Oh, it tells me X is 5, but it also caught an error. That is what? X divided by 0. So it tells me X must be a number. Now this doesn't make any sense. Okay, I can just say, well, an error has occurred. An error has occurred. All right, so let's do this. Well, maybe the user give us AB, an error has occurred. Well, let me do 6. Oh, X is 6, but an error has occurred. But the catch here is when you use except catches every kind of error, and you may not know where exactly something is going wrong. How do we know whether it is a number that the user, an alphabet like ABC that the user has passed, or is the error coming from trying to divide X by 0? And that is why we cannot do something like except value error. We can say something like X must be a number. X must be a number. And then we can now say except, and then we say this zero division error over here. And then we can also then say print, and then we say cannot divide X by 0. All right. So now when we do this, now let's see what we have. What is X? AB. This tells us X must be a number. So we know for a fact that the error came from this value error. We try to pass AB into an integer, a variable that expects an integer. Let me now run this again now. Let me now do 6. Now, it tells me x is 6, but cannot divide x by what? By 0. I can as well use my f string to get the value of x, and then I can do something like this. Now, let me now also show you something. Imagine I pass this one here, and then I use the f string to say x must be a number. So let me do this one first. Let me try to just use a number. Okay, let me say 7. Now, cannot divide 7 by 0, which is the value of x. But now, let me say AB, enter. Interesting. This now tells me name x is not defined. Imagine if I do something like this. Let me do AB. It tells me x must be a number. But if I try to do something like this, let me do AB. It now tells me, oh, okay, let me pull this one up so we see this clearly. Okay, it tells me value error, invalid literal for int with base 10, AB. During handling of the above exception, another exception occurred. So when it was trying to undo an error, an exception, another exception occurred. Why? Because I said int, input what is x. So when the user passes AB, AB cannot be converted into integer. So x at any point did not become AB. So that means x here, this x must be a number. It caught the value error, of course, but I tried to print x must be a number, but this x variable does not have any value. That is why Python cannot print the value of x. Because why? If the user gave us AB, the program rejects the AB even before it associates the x to AB. Before assigning AB to x, the error has already occurred. And that is why we got this error here. X must be a number. It's telling us no. We can't even print x because why? X is not defined. X does not have any value. Alright. So I think that's that. Now another thing we can now do something like reprompting. We have done that in our loops class. And now what can I do? I may do something like this. And then also we can also do, so this also may work with that. We can also use else when you are doing what's it called, when you are dealing with exceptions. You can just do anything. We can look for any other error, all those and all that, and then we can also even print maybe just whatever it is. But you can use else when you're working with exceptions as well. So, but I don't want to go there now. Why don't we come over here and now let's make this our code simple. I don't want to take this, and then let's take this one out. Let's also take this one out. So we don't want to do this. All right. So why don't we try reprompting with this try and except? So I can do something like this. I can say while true, which we have used in the previous class. If you missed the class, please go and check our loops class. That's with 2. So I can put all of this under the while logic here, and I can say while true, ask the user that what is x. Ask the user for what is x, and then except there's a value error, print x must be a what? Must be a number. So if we do this here now, we can now say, let me say AB, x must be a number. Okay, CC, x must be a number. GH, x must be a number. But let me now provide the number. Let me now say something like 6. Okay, s is 6, but it is still asking me what is x. Now when you use while true like this, it is very important that you need to break out of the loop. If you don't break out of the loop, the code, your program will continue to run, unless if that is how you want to design your program. So we can do something like this. Let's say we can take this one away. We can do it anyhow. We can just say, you know what, we want you, once you have gotten X and you have printed X, we want you to break. So break out of the loop. So let me cancel this one with some Control C, and then let's do this. So now let's not try this one. Now what is X? 5. X is 5, and then it broke out of that loop. And then let's say AB. So it keeps asking for it until the user gives me a number. It will keep saying X must be what? Must be a number. 90 now. X is what? X is 90. Another thing I could have done would be to have done something like this. So I can just say once you get X and I want this to break, so I want to break and I want to print what? My X is what? Is X over here. So let's also try this one as well. And then let's say 5. X is 5. Let's say 0. X is 0. Let's say G. No. DD. A, B, C. It keeps asking. If I now do 6, X is 6. So anyhow you decide to run your own program, design your program, ultimately belongs to you. You just have to be smart and reasonable with it. So anyone would have worked. Now we can also do these things with functions. Imagine, let me quickly write a main function. Let me write our function. Let me say def main, and then let's also do this dot first. So we are going to come back over here, and then let me just say okay, and then let's have our main function. Let's call it over here. And now, so for this one, let's give it a function. Let's call this one def. Let's call this one get num. So this one helps us to do what? To get a number. All right, and then we can say something like this. All right, so now we now have let's get this one over here. So let's say this one. All right, so now we have a function called getNum. We have a function here called getNum, and then here we now say, oh, X is this, X is that, and then we just want to do okay, break, and then maybe we just want to, all right, we have a value error and all that. So let's call this one over here. Let's just say something like number equals to getNum. We are calling our getNum function now, and then we want to print what? We want to print the number. But let's see what's going to happen over here. So let's run this code. Okay, 5. Okay, none. Why? Because a function must always return a value. So I can say, okay, once X is gotten, I want to return X. This gives us and again, this is not very interesting. Once we have returned X, I can now see the break. There's now a white line under the X. Now what exactly is happening? Why don't I switch this? So this is okay, why don't I do something like return X? Okay, let's do return X. Now you can see this is bad syntax. Let's do this as well. All right, so now this is also bad syntax, because why? Okay, we have broken out of the loop. After breaking out of the loop, nothing can work again within the scope of this indent. Well, there's something Python now allows us to do. So when you now do return X, return automatically can break out of the loop for you. So when you are doing something with a function like this, you can just return without having to use the break. So let me do 5. You can see X is 5. Let me do AB. All right, CD, F, G, H, and then let me do 5, and then it tells us 5. Another interesting thing that we can also do, instead of even doing this, we can even do something like this. We can even return. So what can we return? We can just return the int of this input. What is X? So we are not even passing it into a variable, we are just returning it directly. So if I do this over here too, let's say AB, all right, GG, and then 5, and then we have what? We have 5. So these are what we call exceptions. So we have type errors, we have many different kind of errors. So let me say except we have different kind of errors. So key error, tab error, name error, type error, index error. Index error is with list. Value error, buffer error, end of file error, EFL, import error when you're trying to import something, lookup error, memory error, system error, timeout error, overflow error, assertion error when you are dealing with unit testing, when you're using a site, recursion error, you're trying to do something recursively, all those are there. Find not found error. So we have a whole lot of error that can be caught as you begin to program. But this here is an idea of exceptions. So that means you can program defensively. You have your user who you are expecting to provide you data or information or whatever it is. You can program defensively so that you can dictate how your program will undo any exceptions, anything that has seemed to go wrong with your with the program. That's going to be all for exceptions. I'll see you in the next class.